Is the code complex or is it complicated? Tough question. Let me put you on a test. I will start writing code, and you start screaming when you think I have gone too far. I'll start with a model, a person with an auto-increment ID and the name. Simple. More. A data source. The class that will give us a stream of objects upon request. Imagine having a database with a similar interface. I will create an object here which will be a good substitute for the duration of this demo. I will need a simulation of a user interface too. Here it is. And a variable will come in handy, and we have hit the first landmark. This application does nothing at the moment, but it has all the parts there: the database, the UI, the model. Is it complex so far? Change of question. Is it complicated? Complicated is what you don't understand when you see it. Complicated requires thinking. Do you have to think to understand this code? I think not, and the primary reason is that I have separated the logical parts and enclosed them into their natural containers, classes in this object-oriented application. I will move the classes away where you don't see them. And that's it, complexity gone. It is around, but it is contained in tiny little boxes where it can grow in time, but we won't be feeling the pressure of that growing complexity because it has been contained elsewhere. And here is the first feature in the application. Its simplicity proves my point. Complexity does exist, but it is contained well at this moment. Let's raise the bar. What if we had to index the people by their ID? I will use a link to convert the sequence of objects into a dictionary, knowing that IDs in the sequence are unique. Displaying the data will sustain one indirection, but my code retains simplicity. Can you imagine the complexity hiding behind these two operations? The toDictionary method and the values property getter. There's a substantial complexity there, but the good news is that that code is not ours. That is the level 2 on the path of knowing true complexity. Level 1 was what you saw before. The complex code you write, but the code that is not complicated, it is easy to manage and it's easy to put somewhere else, to isolate it in its own boxes, in its own containers, so to only use the results of having that complex implementation. Level 2, this is it. It is the code that is complex, that is complicated, but not yours, so you don't care. That is the library code we take for granted without giving it any credit. Sorry, library code, you always looked so cute. And now I will lead you to the bottom of that rabbit hole. I will show you the true complexity. Complex, complicated, your code. How will you survive that? Let's start playing open your mind and think of indexing the people by storing them in a linked list. A puzzle. I will take all the people, adding each to the back of the list. So far so good. But the addLast method returns a list node, and look what I will do. I will index every node in a dictionary addressable by the person's ID. Is this complicated? Yes, it looks so. Would you stop me from writing this code? Oh, wait a minute, I'm not done yet. Do you know what this structure is? I will print it out while you are thinking. Here's the output, just a list of 10 people in the order they came from the database. But let me unveil the mystery. This data structure is the so-called least recently used list. The least recently used item comes first in this list, and the most recently used item comes last. You cannot attain that with only a list or a dictionary. You need both. That's why this code is complicated. And I will keep writing it. Watch me do this. I want to use a random item like the 4th person in the database. Then try to find the list node containing that person. If successful, I will remove that node. Is this complicated? Stop thinking about the code. Try to visualize the linked list in your mind and follow the data. Poke the value from the removed node and insert it at the back of the list. Then reconcile the dictionary to index the new node instead of the old one which I have deleted. You can short-circuit this. You don't need to reinsert the data. The linked list node which I have removed is now outside the linked list, and the list will allow me to reinsert it at the back. So there is a more optimized implementation than this one. I will leave it this way, I don't care. Now fancy printing the list again. Let's run it. Look where the Anders Halsberg is now, at the end of the list where the most recently used item should be. Just as requested, the list sorted descending by the age of the items in it. You don't have to applaud me. This is the cost of magic, complicated code. But this portion of code here, it is displaying the working principle behind the so-called LRU cache, least recently used cache. When that cache hits its limit, it removes the least recently used object to make room for the newly coming one. And here is one rather amateurish implementation of the LRU cache based on the dictionary and the linked list. There are other, better ways to implement the LRU cache than this one I made here, but trust me, they look much worse than this code here. But again, is this code complex? Is it complicated? Yes, it is complicated, but only portions of it are complicated. And I have turned complicated code into complex code by giving names to portions of that complicated code, by wrapping portions into smaller methods that have the name and they explain for their name what they are doing. And then the complicated code was turned into a complex class, the class that has an inner structure, interconnected methods that call each other. But looking from the outside, is that complex? I don't know. Most of those methods are private. You won't even see them from the outside. Let's see, I'm instantiating the cache with a capacity of only 3 objects, and I'm populating it from the database right away. If you think about this, it is a wasted effort because the database is much bigger than 3 items. Anyway, I'm printing out the remaining content of the cache, running the application, and here it is. Only the last 3 items from the database have survived the LRU purging algorithm. And all that complex code, what about it? What complex code? You mean the LRU cache I implemented earlier? Oh, I have put it under the rug while you were away. That is how we manage complexity. We move it away. And that is the story about complex and complicated code. There will always be complicated code. We are solving hard problems with code. It must contain that complexity. But then turn the complicated code into a complex solution. Then wrap that complexity into methods, state transitions, everything it takes. That will turn the problem domain's intrinsic complexity, the complexity that exists in reality, into a complex software solution that is quite natural. And then move it away and walk into the sunset. That may sound unfair. I wanted to brag around and tell everybody how beautifully complex LRU cache I have implemented. There was half a master thesis in it, and all I have got in the end is this lousy variable. Not fair. And do you know how I got this vertical line on my forehead? For years I kept asking, who made this code? And one day, it was there. You never know.